So, dear friends, welcome back. Welcome for the second week of our program. So, in our previous lecture, what we have learned about the overview of the various 3D printing processes, or we also called as the additive manufacturing processes. In this week, we will be mainly learning about the hybridization of these processes, the standard operating procedures, and how can we make a developed process which is hybridized by using more than one 3D printing process. So, to start with my discussion, I am going to present you one overview of the dual material 3D printing. And in this work, we will be working on two thermoplastic materials. One is ABS and another is PLA. And we will see how their 3D printing is helpful for improving the tensile, flexural, fracture properties, and other surface related investigations we will explore in this discussion. One of the important idea in this work will be how to make a standard operating procedure, and can we make a thumb rule within the use of dual thermoplastic material. That is the major area of discussion in this work. So let us start. As an overview, we all understand that 3D printing is, of course, established process since 80s we are using this. And for the specifically polymer materials like ABS, PLA, lot of discussion has been there for their 3D printing. However, when I am interested in the dual material 3D printing, it is still a challenge, right? So let us see this diagram. As you see, I have selected two specimens. One is for the flexural consideration and another is for the tensile consideration. For the flexural specimen, this is as per ASTM D795, and for the tensile, this is as per ASTM D638 type 4. So, as a standard protocol, I need a CAD file. So, we can prepare this CAD file using any CAD software. It may be a SolidWorks, and then making the STL file and then do the slicing. So, we are able to get this for the generation of G code in our any open source software. So, I have used Cura. Any open source software can be used for this. So, as a standard operating procedures, what I need to know, what is the combination for the selection of layers for the dual thermoplastic material, then 3D printing of the flexural specimens as well as tensile specimen, because geometry has already been fixed. Then we are interested in its characterization on a tensile testing setup on basically the UTM. Then the fractured surface analysis, followed by understanding of the surface roughness that has been generated. So in this case, we have used some image processing software, which is a open source, in this case Guardian. So let us see one of the important consideration. As you see, for this work, some of the parameters have been kept fixed, and only the layer combination has been changed. On any open source FDM, like we have fixed the bed temperature. Like here, just I want to remind that this FDM, triple F, material extrusion, these are just overlapping words. FDM is of course a patented technology with the statistics, but after 2018 the patent is over, so most of the researcher they take it as a fused filament fabrication, and as per the recent code given by ASME and ASTM, it has been categorized as the material extrusion process. So these are the repeatable words, right? So what we have done is we have fixed the bed temperature, we have fixed the nozzle temperature, infill percentage, infill speed, number of parameters, raster angle, layer width, number of layers. These have been kept constant for this investigations. And we used here the concept of the random numbers, and by fixing the number of layers as 6, we chose around 12 combination. This was just at random to understand what is the effect on the different layer combination on the final quality of the product. Like in first case, we have printed all the 6 layers with the PLA. So first layer of PLA, so it has been designated with the letter P. So second P, third P. So all 6P means 6 layer of the PLA material. Then in second set of experimentation, all the layers were of a single material, that was ABS. Then in third set of investigations, what we observed, that first layer of PLA, second layer of ABS, third PLA, fourth PLA, then ABS, then PLA, and we tried again the 6 number of layers, and what is the effect on the mechanical properties specifically for the flexural specimen and the tensile specimen. That was the point of investigation. So similarly, all the 12 set of experiments were performed with a different combination of ABS and PLA. Again, here just I want to remember that this is a selection based upon the random numbers. No specific pattern was selected. So these were the specimens that were actually prepared with this combination. So this is the dog bone specimen as per the 12 set of readings that we have selected in this table, and similarly the flexural specimen accordingly. And these were put on the UTM, and we tried to measure their peak load, peak elongation, break elongation, peak strength, break strength, and modulus of toughness. Accordingly, like for the tensile case, all the stress strain curves for all these 12 cases are plotted. As a simple thumb rule, we understand that the area under the curve basically is representing the modulus of toughness. So higher area under the curve is basically the symbol of there is a more impact resistance property with that material. So specifically good for the crash loading application. So now what we observed as a thumb rule, there is a special pattern that is being followed for the destructive testing of this type of material. So we categorize that into the term that is called number of conversion and number of negative conversion. Number of conversion means conversion of one layer of material to the another, and number of negative conversion is if I am basically putting a layer which basically decrease my particular property, we call it as a negative conversion, right? Like see in the first case, all the layers were of PLA. So first layer of PLA, second PLA, third PLA. So there is no conversion of material from one to another. So number of conversion is 0. Number of negative conversion, also there is no negative conversion because all the layers were of the same material. Then number of P, here in this case the number of P's were 6, and number of A, there is no number of A because no ABS layer was selected. Then in the second case again all the 6A were printed, so there is no conversion of material from one layer to the another. Similarly, there is no negative conversion and there is no P and 6A. Now see in third case, first layer of P, then A. So this P to A is one conversion. Then A to P, second conversion. P to P, no conversion. P to A, third conversion. A to P, four conversion. So number of conversions are 4. Right? Now what is negative conversion? Now what we observe that ABS is having a higher TG, that is the glass transition temperature, as compared to the PLA. Now if I print the ABS layer first and then print the PLA over it, what happens? There is a side flow of the material because of the high TG of the ABS, right? So that is considered as the negative conversion, right? Now in this case you see P to A is not negative, but A to P is negative. So this A to P is first negative, then another A to P is second negative. So number of negative conversions are 2. So number of P's are 1, 2, 3, 4, 4P, and number of A's are 2. So similarly in all cases we observed how many are number of conversions, how many are number of negative conversions. Let us take another case, let us say serial number 11. Here A to A no conversion, A to P one conversion, P to A second conversion, A to P third conversion. So number of conversions are 3. How many are negative? This A to P is one negative, then another A to P is second negative. So number of negative are 2. How many P's, how many A's that we can physically count? So there are 3 A's and 3 P's. Now what we have observed for all mechanical properties, maybe it is the tensile, maybe it is the fracture, maybe it is the thermal property, the number of negative conversions should be minimum, followed by number of conversions, followed by P, and followed by A. If I follow this trend, I will have a better mechanical property. So this is one of the thumb rule, and we have published this as thumb rule. And if we follow this, the chances of failure for my product are minimized. And based upon this, we try to correlate it with the thermal property, like in our yesterday's discussion or the previous lecture discussion. What we have observed is there is a special trend being followed in a DSC analysis. Similarly, the observations for the flexural property, in which we observed for the peak load, peak elongation, break load, break elongation, peak strength, break strength, and you can see the stress strain curve, and accordingly the fractured sample, in which the behavior of the sample, and specifically in case of flexural, the angle at which the material was uh, breaking over here is basically following the same trend, means number of negative conversion to be minimum, followed by number of conversion, followed by P, and followed by A. So if we follow this, the chances of failure are minimized. I hope you enjoyed this discussion, and this can be implemented in every field. We try to correlate it with its surface property, we try to correlate it with 3D rendering images, and with the surface roughness observation also. I am going to share with you the actual published document on this, and the web resources that you can see at the end of this session. So there is a good correlation of all the mechanical properties, thermal properties, and morphological properties, and in this way we can actually tune by playing with the number of conversions, number of negative conversions, and we can think of for dual, triple, 4, and even 5 layers of materials we have tried, and it follows the similar trend. So, dear friends, I believe that this information was useful. Till now, what we have observed for our dual thermoplastic material, there is a specific trend being followed, in which by minimizing the number of conversions, number of negative conversions, then followed by number of P and A, we can optimize our mechanical properties. And these are having a close correlation with respect to their thermal behavior, with respect to their morphological behavior, with respect to their surface roughness characteristics. And I believe that all of you enjoyed this. In our coming session, we will see this application in actual environment, specifically for the veterinary and the dentistry application. Thank you very much.